Lenz law. Lenz law. Uninduced current has a direction so that the magnetic field due to the current opposes the change in the magnetic field that induces the current. Suppose we put the magnet into the pole. This is north. Okay? So we will find the induced current will produce magnetic field too. It was always against the change. So this is north to north. You have to repair force, reduce it. Okay. So in this case, the current in this way. This current produces magnetic field. This is north. This is north. So you need force this magnetic field into this way. You do the work. You have to do work, and this work has been transferred to the thermal energy of this loop. Okay. Energy consumed. Let me repeat it. Uninduced current has a direction such that the magnitude field due to the current is north, opposes the change in the magnetic field that induces the current. So this is end-to-end opposite, repair it. This induced magnetic field does not intrinsically oppose the magnetic field. It opposes the change in the magnetic field. That's different. Now, we look this way. Okay. If the magnetic field increases the direction, so it will induce current, which oppose the change. In other words, the induced current should opposite direction. Okay. So this is current opposed to change. Now, if the same V, it decreases, change it. So we go to opposite. What happened? So the induced one will induce a magnet in this direction. Now, look at this. If the magnetic field increases direction, so the induced current will oppose it. We go to opposite. So this is the direction. If the magnetic field decrease, so the induced current will oppose decrease, so it will approach a B this way, so it's the direction. Okay. Electric guitars. We saw a lot of electric guitar in galas, in concert. Okay. This is a metal guitar string. This is coil magnetic field. The oscillations of metal strings are sensed by the electric pickup that is send the signal to a magnifier and a set of speak. As the string oscillates towards and away from the coil, the induced current changes direction at the same frequency as the string's oscillations. Thus, relays the frequency of oscillation to the amplifiers and the speak. Example. Fixtures a conducting loop containing a half circle of radius r 0.20 meter and the three straight sections 1, 2, 3 straight. The half circle lies in a uniform magnetic field of B that is direct out of the page, direct to you. We see all the head of the arrow. Okay. The field magnitude is given by B equals 4.0 t squared plus 2.0 t. Its timing changes, it's not constant. It changes with time, but not with location. Okay. With B in Teslas and T in seconds. An ideal battery with electromotive force 2.0 volt is connected to the loop. The resistance of the whole loop is 2.0 ohm. Question A. What are the magnitude and the direction of the electromotive force induced around the loop by field B at t equals 10 seconds? B is a change with time t, so this is give you the time at this moment what is induced electromotive force. By definition, epsilon equal to minus d phi b dt. Here, d phi b dt only this part. This is no magnetic field. So b dot dA. If b, we choose to A. B is parallel to A, and in the same direction. B is this direction, the A is direction. So we change the counterclockwise is a positive number, A, okay? It's towards you. So B dot dA equal to BA. BA. This we from this to this, we means B parallel to A, and B is in the same direction as A. So A is this direction. So B is direction. A is direction. So this is loop's direction is counterclockwise. Is when we do this one, we assume this is a current, positive current direction, counterclockwise. So we put this one inside. A is a constant, so dB dt. Then we get epsilon equal to minus d phi dt. Okay. Then epsilon equal to minus A is this one, half pi r squared. dB dt. B is 4.0 t squared plus 2.0 t plus 3.0 dt. And this one, we do the derivative, is 8.0 t. This one, 2.0. This one, 0. So we get epsilon equal to 8.0 t plus 2. And this t is 10 seconds. We put the t in 10 seconds, we get epsilon. You see this one number, this is minus number. What does this mean? This is clockwise. Clockwise. Epsilon, this one, and this is clockwise. Why? You see, d phi dt is a positive number. That means it goes more and more. And so the induced current must against it. So you produce flux. B is this one. So the current direction must be clockwise. You can produce E against the change. Question B. What is the current in the loops at 10 seconds? This is I epsilon net of I. Remember, we have connected actual electromotive force. And this is direct direction. And our direction is clockwise. So we look at the clockwise. This is E induced minus E battery. This direction is this direction, clockwise.